present my, I would say, my PhD plan titled Tensor Decomposition Based Machine Learning Approach for Epilepsy Seizure Detection using EEG signals. So, my presentation, I will provide some motivation first, and then we provide EEG data representation and the motivation for this, for the use of EEG data, and the ongoing and perspectives of my work. So, basically, epilepsy is a chronic neurological disorder affecting a significant portion of the psychiatric population. It can occur in humans and animals from primary or causal sources, okay? And it can have life-threatening consequences, of course. So the role of the neurologist is critical in diagnosing epilepsy. So they usually use electroencephalography, the EEG data, yes, to detect some kind of seizures, to detect including epilepsy. So the EEG exam is one of the most famous exams for detecting abnormalities in brain signals. Okay, regarding the EEG data, my God.
I think that you have to come a bit closer.
Okay.
Because it's often optical.
Okay, so regarding the EEG data, this is a representation of the arrangements of the electrodes in the scalp. So each point here is a channel, yes? So this version of the EEG exam is a non-invasive version called scalp version, all right? But there are a lot of course, version of this exam, including the invasive exam, and we can see in some works called intracranial EEG exam or intracranial EEG data. The reading of the data is usually made by the intracranial, but this version is most common version exam. Okay, so this is a representation of EEG record. Okay, this is actually a time series of the amplitude of the signals from each channel. So here we have 23 channels, and I would like to say more about the organization of some database. Some database organize in subjects. This is from one subject, and understand subject as patients, okay? And one subject is actually one folder, and in each folder there are several records, and some records is labeled with the seizure. In this case, I am interested to work with the epilepsy seizure. So there are several public database and also private database. I am pointing 4 of them. I suppose they are the most famous database, yes. The last one called Open Neuro database. They are data for animals also, the humans and in animals. I just found this database just like 1 week ago. Wow. And of course, there are some challenges involving this EEG data, okay? One of them is the multidimensional structure. Remember when I said that the subject is organized into folder, and each folder has recordings. So we can organize we can stack that matrices into tensors. So we can organize our tensors using each channel and time and make our tensors. And it means a high storage demands, of course. The CHB MIT Scalp database, for example, we have 45 gigabytes, so it's too complicated. It means a significant computational cost for training reliable machine learning models, deep learning models and stuff. Yes. So we can see some, of course, there are another database that demands more storage, but this is one example of one of them. Okay, and here we can apply tensor decomposition models, for example, in order to compress our data, yes, while preserving some essential information, yes. We can apply, for example, the parallel factor analysis and Tuck decompositions, okay, and it enables efficient training of machine learning models, deep learning models also, anyway. So this is the representation of the pair of fact and this Tuck decomposition of a two-way tensor. Okay, the pair of fact is a sum of finite number of rank 1 tensors, and the Tuck we can understand as a high order PCA. Yes. So we can apply these two models, and I have a great interest to begin with the pair of fact. So this is just a draft of my methodology. Of course, I'm not pointing the specific points here, but this is as a general, just an overview of my methodology. Okay, we can, in this methodology, we can just choose 3 or 4 subjects, okay, and make some pre-processing step, and then construct our tensor. Yes. Finally, apply the tensor decomposition in order to compress the data, and then feed the ML model, and then make the classification, and finally evaluate our model, but not just evaluate in terms of accuracy, precision, sensitivity, but beyond that, in terms of runtime, processing time, and stuff, yes, which is too important in this approach. And the ongoing and perspectives of my work, what I have been doing is literature readings. I've been reading some papers and taking some ideas, methodology and stuff. Of course, my studies in algebra multilinear is ongoing also. I've been working my own library, Python library, that I would like to improve my, to apply some algorithms and stuff. And as perspective, as I said, I would like to choose that methodology, and of course, I would like also to apply some methodologies from the literature in order to understand better the problem, and also, who knows, using the CHB MIT data, evaluate this model, this methodology, sorry, and perhaps compare one method without tensor and another one based one, and make some performance evaluation in general. So, yeah, and of course, to evaluate the runtime, the processing time. Okay, so that's it. Thank you guys for your attention. Thank you, André, for this opportunity, and also Professor Tarcísio. I'm so glad to be here, and that's it.